Hello students, let's continue with exercise 2.3 of finding the using the remainder theorem, and we'll continue with sum number 1 option 3. Okay. So as we did in the last session, we found the remainder using the remainder theorem as well as the long division method. We are going to follow the same strategy now. So using remainder theorem, first of all you have your sum as this is your polynomial term, and you have to find the remainder using x as the quotient. So 0 of x is 0. How? Because x is equal to 0, right? So substituting the value of x is equal to 0 in P, we will get the remainder, right, using the remainder theorem. So P0 is going to be 0 cube plus 3 into 0 square plus 3 into 0 plus 1. So all these terms are 0 plus 0 plus 0 plus 1. So P0 gives me 1, which is the remainder when Px is divided by x. Now let's find the remainder using the long division method. So my polynomial is x cube plus 3x square plus 3x plus 1. I have to divide it by x. This is going to be a very simple one. So x into what is going to give me x cube? X into x square is going to give me x cube. 0. I am going to get down the second term, 3x square. X into what is going to give me 3x square plus 3x, right? X into what is going to, okay, I will get this down first. X into what is going to give me 3x into 3. I will get down my last term, which is 1. X into what is going to give me 1? Nothing. So my remainder is 1. Let's compare. Yes, we have the remainder as 1 using the remainder theorem and the long division method. Now we will go ahead and solve the fourth and fifth sum as well. So using remainder theorem, the fourth sum, the 0 of x plus pi is what? Let's find out. X plus pi is equal to 0, therefore x is equal to minus pi. So 0 of x plus pi is minus pi, therefore we are going to substitute the value minus pi into this polynomial. So p of minus pi is what? Minus pi the whole cube plus 3 into minus pi the whole square plus 3 into pi plus 1. This is minus pi. So minus cube of a negative number is always negative. So minus pi cube plus 3 minus pi square is going to give me pi square. So 3 pi square minus 3 pi plus 1. Let's see if we can cancel anything. No, we can't really cancel anything. Let's solve using the long division method. X cube plus 3x square plus 3x plus 1. Okay, and I need to divide it by x plus pi to find the remainder. Now as you can see that the remainder using the remainder theorem method is really huge. So this doesn't look like an easy sum. Please pay attention while I solve it. The first step is very simple because you need to find the first term, x cube. So x plus pi into what is going to give me x cube? X plus pi into x square is going to give me x cube as my first term. So x cube plus x square into pi will give me plus pi x square, right? I subtract this term gets cancelled out. Now you have 3x square plus pi x square minus pi x square. I need my x square as the common term outside, and inside I leave 3 minus pi, right? If you do not get this, look over here, 3x square minus pi x square. I just need my variable term outside. So I am just going to take x square outside and write it as 3 minus pi. See, when you open the bracket, you get 3x square minus pi x square, which is nothing but 3 minus pi x square. Okay, so 3 minus pi x square. Now I get down my other term, which is plus 3 pi. Plus 3x. Let me erase this because we will be needing a lot of space for working. So x plus pi into what will give me 3 minus pi x square as my first term. So I write x plus pi as it is. Now into what will give me 3 minus pi x square. So first of all, for x square we need to multiply it by x, and the coefficient, let's say the coefficient is 3 minus pi, let's say it is a. Okay, so we'll consider 3 minus pi as a, right? 3 minus pi a. If this would have just been a, we would have written this as x plus pi into ax, correct? So 3, instead of a we are just writing 3 minus pi, simple. So obviously you get your first term 3 minus pi into x square plus 3 minus pi into pi x, right? Now this is nothing but 3 minus pi x square plus, I just need my variable term outside, so I am going to take 3 pi inside. So this becomes 3 pi minus pi square into x. Okay, because this will make the sum really easy. Okay, so 3 minus pi into x square plus 3 pi minus pi square, 3 pi minus pi square into x, right? Now this is a positive term, so it will become negative. Negative is for this entire term, 3 minus pi into x square, and again this will also become negative. So what is negative? 3 pi minus pi square into x, this entire term is negative. This gets cancelled, okay? Now we have 3x minus 3 pi minus pi square into x. Now I just need my variable term outside. So I am going to take x common out, okay? This becomes 3 minus 3 pi minus pi square, correct? So this becomes x into 3 minus 3 pi, minus into plus gives you plus minus, and minus into minus gives me plus, so plus pi square. Fair enough? So this is nothing but into x, right? So this is 3 minus 3 pi plus pi square into x. We are not yet done. We still have this term to come down, okay? So I am bringing plus 1 down. Now x plus pi into what will give me this term, 3 minus 3 pi plus pi square x. We already have x, right? So multiply it with this term will give me the first term, which is 3 minus 3 pi plus pi square. Let me just quickly erase this and solve it for you. So pi x plus pi into what is going to give me this term, into 3 minus 3 pi plus pi square. This will give me 3 minus 3 pi plus pi square into x plus 3 minus 3 pi plus pi square into pi, right? So I am just going to take my pi inside. This will come as it is, 3 minus 3 pi plus pi square into x plus 3 pi minus 3 pi square plus pi cube. Correct? Okay. So, oh, I missed writing the term over here. This was plus 3 minus pi into x, right? So now plus 3 minus 3 pi 3 minus 3 pi plus pi square. Right? So this will be 3 minus 3 pi plus pi square x plus this term. I'll just erase it and shift this a little bit over here. 3 minus 3 pi plus pi square into x plus 3 pi minus 3 pi square plus pi cube. This entire term cancels out, so you are left with 1 minus 3 pi minus 3 pi square minus pi cube. This can further be rewritten. Let me just check if this is plus. So when the sum is usually wrong, you will end up making mistakes in the signs. So solve this sum very neatly, very carefully, take your own time, but just make sure you don't goof up like I just did now, because you will lose a lot of marks and it will be an infinite loop. This can be written as 1 minus 3 pi, minus into minus gives me plus 3 pi square, minus into plus gives me minus pi cube. Now I am just going to arrange it in descending order of the exponent. So this is minus pi cube plus 3 pi square minus 3 pi plus 1. So this is my remainder. Let's compare it. Minus pi cube plus 3 pi square minus 3 pi plus 1. Bingo, we have solved the sum using the remainder theorem as well as the long division method. So do you understand the importance of remainder theorem now? It is a shortcut and really saves a lot of time. But you should not even underestimate the long division method, because when you go higher up and especially if you take up maths as your majors, you will be using long division a lot. So just don't forget it. Keep your basics strong. Anyway, we'll proceed further to the last sum of section 1. So the fifth one, you have 0 of x plus 5, 2x plus 5 as what? We'll find out. 2x plus 5 is equal to 0. So 2x is equal to minus 5. Then x is equal to minus 5 upon 2. Right? I'm going to substitute x is equal to minus 5 upon 2 in this polynomial expression. So I get p of minus 5 upon 2 is equal to minus 5 upon 2 the whole cube plus 3 into minus 5 upon 2 the whole square plus 3 into minus 5 upon 2 plus 1. Let's just continue over here. So p of minus 5 upon 2 is First of all, cube of any negative number is going to give me is going to be negative. So 5 cube is 125 upon 2 cube, which is 8, right, plus 3 into square of a negative number is positive, so 25 upon 4, right, and you are left with minus 3 5s are 15 upon 2 plus 1. Let's just solve the brackets first following the rules of BODMAS, and then find the denominator solving the fraction. So minus 125 upon 8 plus 25 into 3 is 75 upon 4 minus 15 upon 2 plus 1. We need to find the LCM of 8, 4, 2 and 1. So 8, 4, 2 and 1. The LCM is 2 4s are 8, 2 2s are 4, 2 1s are 2, 1. 2 2s are 4, 2 1s are 2, 1, 1. 2 1s are 2, 1, 1, 1, 1. Right? So the LCM is 2 into 2 into 2, which is nothing but 8. Right? So now I am going to equate the denominator, make the denominator common so that we can add up the numerators. Right? So 8 into 1 is going to give me 8, 4 into 2 is going to give me 8, so I am going to multiply this as the numerator with 2 also. 2 into 4 is going to give me 8, so 15 into 4. Now 1 is nothing but 1 upon 1, right? So 1 into 8 and 1 into 8, correct? So now we have minus 125 upon 8, 75 into 2 is 150, so 150 upon 8, 15 into 4s are 60 upon 8 plus 8 upon 8. Now common denominator helps in solving the fractions. This is minus 125 plus 150 minus 60 plus 8. Okay. So we have 2 negative numbers and 2 positive numbers. We will solve them separately. Minus 125 and minus 60 is going to give me minus 5, 8, 1, minus 185, and plus 150 plus 8 is going to give me 158. Our answer would be negative because this is the greater number. So 185 minus 158. Different sign, so subtract. That is why 185 minus 158, 8, 9, 10, 8, 9 and 7. This is 7 minus 5 is 2. Okay, so you are left with minus 27 upon 8. You cannot solve this further, so this is your remainder, minus 27 upon 8. We do not have much space to solve this sum by using the long division method. So for now I am just going to note down the remainder, which is minus 27 upon 8, and then compare it. Okay, I am erasing the rest of the stuff on the board. Okay, so the long division method, you have x cube plus 3x square plus 3x plus 1, and you need to divide it by 2x plus 5, right? So what are you going to multiply 2x plus 5 with in order to get x cube plus 3x square? First of all, we need x cube, so x square divided by 2. X square divided by 2 will give me x square divided by 2 into 2x is going to give me 2x square upon 2. 2x cube upon 2. So 2 and 2 will cancel out, right? That is why I am taking x square upon 2 plus 5x square upon 2. So this is nothing but x cube plus 5x square upon 2. Got it? give me x cube plus 5x square upon 2. You cancel this out. Now 3x square minus 5x square upon 2 will give me 3x square minus 5x square upon 2. So the LCM is 2 because 3x square upon 1, 3x square is nothing but 3x square upon 1. So you are going to multiply this by 2 in order to make the denominator common, right? So this will be 6x square minus 5x square upon 2, which is nothing but x square upon 2, right? So you get x square upon 2 plus 3x. Now 2x plus 5 into what is going to give me x square upon 2 as my first term. 2x plus 5 into what is going to give me x square upon 2 as my first term. First of all, let's check the variable. You have x square and x over here. So you are first going to multiply it by x. So you are sorted with x square. Okay, now you want it upon 2. So you are going to look at this coefficient. 2 into what will give you 1 upon 2. So 2 into what will give you 1 upon 2. I will keep this as y, right? So y is equal to 1 upon 4. So 2 into 1 upon 4 is going to give me 1 upon 2. So I am going to multiply this by, divide this by x upon 4. So 2x into x upon 4. Let's check. 2x into x upon 4. What does it give you? 2 1s are 2, 2 2s are 4. X square upon 2. There you go. So you get this as x square upon 2 plus 5 into x upon 4 gives you 5x upon 4, right? So plus x upon 4 gives me x square upon 2 plus 5x upon 4 or 5 upon 4x. Subtract, these two terms cancel out. Now you are left with 3x minus 5x upon 4 or 5 upon 4x. So 3x minus 5 upon 4x. The LCM in this case is 4. Why? Because 3x is nothing but 3x upon 1. I am going to multiply this into 4 as well as this into 4, right, to make the denominator common. So I get 4, 3 4s are 12x minus 5x. So 12x minus 5x is nothing but 7x upon 4. So this is sign of greater number, 7x upon 4. I get down 1. I got down 3 over here, 3x here. I will get down 1 finally, right? So 2x into what, 2x plus 5 into what is going to give me 7x upon 4 as my first term. Let's find it out. You can simply do it by this. 2x into y is, so you have to find what is y. Into y is going to give me 7x upon 4, right? Since you want to find this term, you keep it as it is. So y is going to be 7x upon 4 into 1 upon 2x, right? So x and x cancels out. This gives me 7 upon 8. So 2x plus 5 into 7 upon 8 is going to give me 7x upon 4. And this calculation is simple. 5 7s are 35 upon 8, right? So 2x plus 7 upon 8 gives me 7x upon 4 plus 35 upon 8. This term cancels out. Now let's check 1 minus 35 upon 8. LCM is 1. So 8 minus 35 upon 8. 8 minus 35 is what? 22. 35 minus 8. 27. So this is minus 27 upon 8. Let's compare the denominators. Yes, we have 27 upon 8 minus 27 upon 8 as the remainder in both the cases, using the remainder theorem as well as using the long division method. So with this we wind up section 1. It was a pretty long section of exercise 2.3. We will continue with the rest of the exercise in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.